Hey, I wanted to share with you all a little project I've been working on for a little while. This is a board for the STM32F0, and I've been wanting to integrate these STM32 microcontrollers into some of my other projects, and I thought I'd just start out making kind of an Arduino Nano-sized board for one. So I just wanted to do this simple board to start with. There's plenty of other things like the blue pill out there that people can use that work just fine. I just need to know how to do this myself. So the best way to do that, I think, is just to try it yourself, make a bunch of mistakes, fix them, figure it all out. So just a simple board to start with. It's programmed through the SWD interface over here, and that just goes in directly to it. The USB interface is here for power. But you see here the data lines are not connected at all. So that just runs into this 3-volt voltage converter. And then the pair of caps here they need to be near specific pins. That's recommended in the datasheet. So just if you do something like that, it's nice to note that on the schematic. Crystal here, I may not solder this to the board. I might just leave the pads there, at least at first. It does have an internal oscillator that isn't very accurate, but might be good enough for just fooling around. But I wanted to make sure that the pads are at least there in case I wanted them. And we've got a pair of LEDs here. So the one on the right is connected to VDD, that's 3 volts in. So that just makes sure that the board is powered, that's a red LED. And I have here as well one connected to PA0, I believe that's physical pin number 6 on the chip. And so that you can just blink with a program without having anything else connected, just power. And then a couple of pin headers that are connected into all the pins on this. And there's no switch on this either. There's no real convenience features on this board. It's just straight, here you go. So now let's take a look at the PCB. So here's the PCB for it. And you can see it should be the same size as an Arduino Nano, or very close to it at least. It should pop into the breadboard just the same with these pins. And let me take off the zone outline here just so you can see the traces a little better. So these unconnected traces are all ground. The ground plane is just connected to ground on everything. The big fill-in plane, I should say, is connected to the ground. And the crystal's on the underside of the board. And you got the SWD interface down here. And one little thing I'm not totally happy with is to make the power LED fit, I bumped the USB micro connector over, so it's kind of asymmetric like this. That just means I didn't want to interfere with all these lines here. And I still wanted the power LED to be close to the USB connector. Okay, that's what I'm missing. Okay, this is your power connector. So that one's going to be red. And if you see that on, it means the board should at least be getting power through the regulator. And then this one gets controlled on PA0, which is physical pin 16 on this pin header. So it starts with pin 1 down here, and then it's pin 16 there. And that does go to physical pin 6 on the chip, if you follow all that. Anyway, so that's your GPIO LED. That, as long as the board's powered, that should work, and you can blink that in a program for testing purposes. That's pretty much the whole board. I based this all off a tutorial that I found online, which I'll link in the description. If you want to make something like this, I'd suggest going through that tutorial. It's pretty good information. And I've got this all ordered up through Oshpark. I've got all the parts I need. For 3 boards, it was about $6 through Oshpark, so not bad. And then the BOM cost, I think was $30 for just all the other parts, including the programmer. So it's not as cheap as some of the blue pills you can get online, but it's not bad. So yeah, I hope this will work out. I'm going to solder this up. The parts should come the next couple days, and we'll see if it works. All right, thanks for watching.